In this video, we're going to confront manipulating, again, multivariable equations, but more than one. And this is actually kind of a common problem you see a lot, say in a calculus class or even in algebra, rewriting areas, in terms of, length and width in a rectangle as one or the other. So to kind of show you what I mean here, it says we have 40 feet of fencing, which we want to enclose a rectangular garden with. So we say express the garden's area in terms of its length only. Okay, so 40 feet of fencing to use to enclose a rectangular garden. I think the best thing to do is let's just go ahead and start by sketching the situation. We have our rectangular garden here, and what we know about rectangles is that they both have a width and a length. Okay, and our idea here when saying we have 40 feet of fence is actually just to kind of point out that if we were to wrap 40 feet of fence around this, we'd have a perimeter that is 40 feet. Okay, so first thing we want to do is express our perimeter formula, which, by the way, we don't need to memorize the formula or recognize it. We can just piece it together from this. We say 2 lengths plus 2 widths. This is our perimeter on the outside. But it also says, please and thank you, express the garden's area in terms of its length only. And what we know about area is that it's equal to length times width, geometrically speaking. Okay, so basically what they want us to do is this. They want us to write the area in terms of its length. In other words, let's get length by itself, or not length by itself, but let's write area so that there's no W on the right hand side. Okay, so in order to do this, what we're going to do is we're actually just going to plug in this piece of information we were told right off the bat. If we know that the perimeter is 40 feet, this is going to allow us to substitute that into this equation up here. And the nice thing about that is if we go ahead and do this, we say 40 feet is equal to 2 widths plus 2 lengths. What we wanted to do in this first equation up here was rewrite this so that it's only in terms of L's, it has no W's. So our method is going to be to do this. We're going to solve for W in the second equation, which is this one right here. Okay, we'll call this our first and our second. But we're going to solve for W in this equation, even though it has another variable in it. And what we're going to do is we're going to say, well, now that we know W equals something, something, something with L's in it, we're going to take that and we're going to go ahead and plug it in up here. And then we'll have all L's. Okay, so let's go ahead and start with manipulating this equation here. We need to get rid of both this 2 and this number here, 2 times L. So we need to start with, let's get rid of this positive 2L. We're going to subtract 2 lengths from both sides. And what we end up with on the left is this. 40 minus 2 lengths is equal to 2 widths. And again, to get W by itself, we would divide by 2 here. Okay. Nice thing is we have a monomial divisor, which means 40 divided by 2. We could, individually take everything on top divided by 2 in the basement. But 40 divided by 2 is 20, and then negative 2 divided by positive 2 is a negative 1. So we get this. We get the width is equal to 20 minus the length. Now, again, like we mentioned here, we've gotten our expression right here that we wanted. The width equals something in terms of L. What we're going to do is we're going to now go and say, well, our area formula. Our task in the first place was to rewrite this area with no width in it. We wanted all lengths. And so now that we know what W is, we can actually come back over here. We say it's really length times width, but for width we can instead put 20 minus L. And so what I want us to realize is this. What this really represents is the area. This is the area of this rectangle, only written in terms of its length, but only if and only if the perimeter in the first place was 40 feet. If we had gone back and changed this 40 feet to say 100 feet, what that's going to do is it's going to affect this little value right here, which affects the area. Okay, but a very common problem in which we're rewriting multivariable equations and using more than one in substitutions. Cheers.